3, 2, 1, Mark. No, you're not supposed to clap and say Mark. Hey, that's audio recording.
Yeah.
What are we talking about today, Dan?
Yeah, audio recording.
Yeah.
This show is brought to you by Interesting Radio. You can find all our shows over at interestingradio.nz.
We're born with a natural curiosity, and we have an open mind. We want to learn things. We want to learn how to...
And I am not a visionary. I do not have a 5-year plan. I'm an engineer, and I think
Just plug it in. It's going to say, hey, I see you plugged in a new device, and it's going to load in the appropriate drivers. You'll notice that this scanner build... Whoa.
So, Mike, it's one or the other, right? Not both.
Yeah, sorry. I'm new to this audio recording thing, right?
Well, lucky I'm going to tell you all about it today.
Oh, very good.
Yeah. So audio recording, which is kind of what we're doing right now.
I thought we were having a chat, but okay. No, yes, we are. Okay.
So let's start with a bit of a history. First audio recording was actually made in 1860.
Wow, that's actually further than I thought it was.
Yeah,
I thought it was like 1880, 1890,
But in 1860, there was no method to play it back.
Ah, of course. Yes, that's right.
Yeah, so basically it was a stylus that moved across some paper with charcoal across it, and when the stylus moved, it moved the charcoal out of the way, and that left kind of an imprint of the airwaves that, the people's voices and things like that.
So was the charcoal loose, or was it like a powder? So if
so it was a powder.
So if you knock the paper, it's gone.
It's gone. Yeah.
Did they bake it or something to keep it, or
they must have done, because we actually have a what they did in 2008 was they took one of these. I think the earliest one that they had.
Yeah.
Took a photo of it and then used computers to play.
Oh right,
back.
yeah, okay, to do image work and yeah.
Yeah, and this is what it sounded like. It's a from 1860, a recording of Claire de Lune.
Okay. Wow, that's actually quite impressive, really, for a first recording of something ever.
Yeah, so that is the earliest known recording of the human voice.
Wow, yeah. It almost sounds like someone humming rather than singing, isn't it? Yeah.
Yeah, absolutely, and it's just amazing that it was that far back.
Oh, that's incredible.
Yeah. So that was kind of the first thing, but yeah, they didn't have any way to play it back because it was just, lines on a piece of paper.
Yeah.
So next, in 1885, which is what you were thinking of, I presume, was the disc phonograph.
No, the one I'm thinking about is the one that's on a drum.
Yeah.
That's that one. Right.
This is the wax-covered drum.
That's the one I'm thinking of. Yep.
The same stylus, but because it's wax, once it's set, then you can play it back. And we actually have a recording of Alexander Graham Bell's voice.
Oh wow! Okay.
That was Hear My Voice, Alexander Graham Bell.
Oh, yeah, it's excellent.
It's so cool. That was such a long time ago.
It's such an important figure in history of this sort of technology as well. But
yeah,
it's interesting whenever you listen to very old recordings and things. There's always a completely different way people present themselves with their voice, and he his diction there was just perfect, and the way you listen to the way he says Alexander, it's
very
very particular.
Precise.
Yeah,
absolutely.
But that's the same with all. Everything that's been recorded that I've heard of from that era is very particular like that. It's quite fascinating.
Yeah, and there's because that's all we have, you don't really know, did everyone always speak like that, or was it just for the recording?
Was that your recording voice? Yeah. Or
yeah, exactly.
Your phone voice.
yeah, the voice that everyone has when they talk to an answer machine.
Yes, that's right.
So yeah, the disc photograph kind of went on and became the vinyl that we all know now.
Right. Yep.
Yeah. So that was what they called the mechanical age of audio recording.
So the recording was the needle in the I guess you can call it the medium, I guess, the wax or something. And the vibrations from whatever was used, the microphone system was used to pick it up, the vibrations of the needle would make complex patterns in the wax, right?
Yeah.
And then to play it back, you put another needle in that vibrates with those patterns as well. And
reverses the process.
Reverses the process, that's right.
Yep. Exactly.
So it's not just a slot. If you actually get a microphone in there's lots of little micro bumps and things, right? That's how it works, isn't it?
Yeah.
Yeah.
Yeah. Yeah. So because it's so microscopic to us,
right.
it looks like
just lines, but
but it's actually much more detailed than that. 1945, the electric age of audio recording started. Now this is not the electronic age. This is the electric age. So this is where the master was still a wax disc.
Right.
Even for vinyl, the master was a wax disc because it was still the...
Of course, because we're talking about recording here, but not transmission.
Yes.
Because they had radio before that, but they weren't recording it. They were just...
Right.
Right. Okay.
Yeah. So we're talking specifically about recording.
Right.
I will talk a bit about transmission later on, but this is...
Okay.
But that's a side topic. So you had microphones, like the kind of close to the microphones we know now, but they were still moving a stylus which imprinted on a wax disc. So the medium didn't change, but the method of getting onto the medium did.
Okay.
And then in 1950, roundabout, magnetic recording came along, so recording to tape. So then in 1950 roundabout, along came magnetic tape. So the big spools, of course, were kind of where it started.
Whenever I think of magnetic tape, definitely think of the old server equipment back in the James Bond films of the day, and
You can get audio players that run that kind of stuff as well, which people use sometimes, and the quality is actually really, really good. But like they say, going back to vinyl. Vinyl is still pretty much the best quality audio recording you can get.
Yeah, well, it's I guess you could say it's analog still, right?
Yeah.
Is it going from a nice, analog is pure mathematics of curves and things like that. Your analog signal is going to replicate the ups and downs of your sound waves perfectly, but if you have to turn that into digital, you got ones and zeros which can't do the curves and things exactly right. It's a stepped curve, so things that are analog will sound much better always.
Yeah, and that's where the kind of the frequency of recording comes in as well. Like we're recording this at 48 kilohertz, which is the amount of amount of data that we're capturing per second.
48 kilohertz recording 20 years ago, be like, oh man, I don't have a hard drive big enough for that.
Yeah, exactly. So that was 1950, and then in 1975, the first digital recordings came along. So that was when the PCM codec started. So this is computer-based recording.
Right, so we better talk about codecs, do we?
I suppose so. So PCM is kind of, you think of a CD, that's right. PCM. So that PCM, I don't know what it stands for. Let me look it up. So PCM is pulse code modulation. So basically it's digitally representing analog signals, and it's it's almost exact replication. So it's kind of the best quality you can get. You don't lose any information.
Right. Okay. So step back a step. What is a codec? What does it mean?
So I guess codec comes from code and decode.
Yeah. So codec is a device or computer program for encoding or decoding a digital data stream or signal. So it's a way of representing that information in a stream of data in a computer. So it's turning that analog waveform of nice beautiful sine waves of your audio from your voice or your music or whatever, and then turning into ones and zeros to record it. Yep.
Yep, exactly. So you think of like WAV and MP3 and that kind of thing. Those are all codecs.
Yeah, that's an interesting thing, right? I remember when MP3s first became known about, and was it Fraunhofer, I think, or Fraunhofer, however you say it, was it university, I think, that developed it? I forget anyway. The patent was with this German people, and
which
it was
just recently expired.
That's right. And I remember getting the first few MP3s and thinking, oh wow, it's taking up so much space on my hard drive. This 4 or 5 megabyte file, which is got this song in it, and you play it, and it just sounded amazing compared to all of the things we had on computers back then. To have a complex song, you'd have a absolutely massive WAV file, as some people have heard before. Commonly, all the computer sounds on your computer, your startup sound and your alert sound and your wee bong and your bing and all sorts of things, they're usually WAV files, right, sitting in there and part of the operating system, and they're kind of small. But when you actually record a song, I think a WAV file comes out 60, 70 meg or something usually.
Yeah, because, a CD is 700 meg, and you usually get about 80 minutes of audio onto that.
Yeah, so you divide it up into lots of about, 4 or 5 minutes for a song.
Yeah, about 3.5, I think.
Yeah, something like that. So you end up with about 60 or 70 megs. I mean, that's too big for storing all your music. Although some people still do. Those people we call audiophiles. People who like their music, they typically don't like using things like MP3, because MP3 is a compression. It's taking...
Yeah, so it's yes,
I'm getting ahead of myself, aren't I?
You are.
Sorry.
So we will come back to compression and MP3 and everything a little bit later on.
Okay, I'm sorry.
Yeah, so that 1975, DAT, CD, things like that. And then MP3 came along in 1993.
Yes.
Yeah. That's a kind of really quick history. So now I'm going to start moving along the chain and start with microphones.
Okay.
So there's 3 kind of common types of microphones. First one, which was also the first one invented, was the ribbon microphone. Basically, you had a ribbon of metal, aluminium or something like that was suspended between 2 magnets.
Okay.
And when your voice or, traffic or whatever the noise
right.
passed across it, it made it move backwards and forwards between the magnets.
Right, because noise or audio is vibration of air, right?
Yeah.
So it's vibrating with the air that's around it. Yeah. Okay.
And that generated an electrical current.
Because it's between the magnets, right?
Between the magnets,
right.
So electromagnetism and moving the magnetic fields, which causes it to generate current.
Oh, that's very clever.
Yeah, so that was the first one, and you can't beat the sound of a ribbon microphone.
Oh, I imagine you can't.
They're very, very, very expensive.
Very expensive, but probably also very delicate, I suspect.
Yes. Oh, absolutely, because you've got this tiny paper-thin bit of metal. Yeah. That leads us on to dynamic microphones, which is what we're using at the moment.
So I'm completely green with microphones. I don't know the technology very well, but isn't the same principle still in effect as a modification of a magnetic field of some description?
Correct. So a dynamic microphone is actually the magnet that's moving.
Oh, wow. Okay.
So at the front of the microphone, you have a diaphragm, just, like a metal plate or plastic plate that moves with your voice.
Okay.
And it's got a magnet attached to it.
Right.
So when you talk, the magnet moves backwards and forwards inside a coil.
Okay. Yes.
And that generates the sound. The electrical current. So it's kind of the same as the ribbon, but they're a lot more robust.
Right.
Because you don't have this tiny piece of metal. So dynamic microphones are what you see, rock singers and everything with, because, they can get slammed on the ground and everything like that, and they'll still carry on working.
Okay, right. Explain to me then, I've always, well, not always, but I've heard the term a lot, electric condenser. Is that a dynamic microphone, or is that...
No, so that's a condenser microphone.
Okay. Are you talking about those?
That's what I was coming on to next.
Okay, very good.
So that microphone that's sitting on the desk beside you is a condenser microphone.
Poor little thing sitting over there, disconnected, not being used.
So condenser microphones are a lot more sensitive, which is why I've stopped using it, because when we're sitting across the desk from each other, it picks it up really, really easily.
So it's great for a room mic, but not so good for...
Yeah, or if you're by yourself, or a singer.
Okay.
Or things like that. So that it works on capacitance.
Okay.
So basically you have a diaphragm again, and then you have another plate behind it.
Okay.
And as the airwaves move, it changes the distance
between the plates.
which changes the capacitance of the circuit,
Right.
which generates the electrical current that makes the sound.
So I'm sure at some point in the future we'll perhaps talk about electronics and the basics of some of the components. But so we should just very quickly mention that a capacitor is it's a device that kind of stores charge, and it works by having two plates with what's called a dielectric between them.
Yeah.
And the distance between the plates dictates sort of kind of how much charge it can store and all the properties of this, and to do with electrons sort of wanting to get across the gap, but they can't because of the distance and things like that. So we'll come back to that, but that's the basics of a capacitor. So what we're looking at, if I'm correct, we're talking about an electric condenser microphone, is that change in capacitance because of that distance between the plates based on your vibration of your voice through the ear.
That's right.
Right.
Yeah. And condenser microphones need power to work,
Right.
because it needs something to store in the capacitor.
Very true.
So that's where phantom power comes in. So phantom power is 48 volts that comes along the microphone cable.
Oh, okay.
And
So some microphones don't have power.
correct. So dynamic microphones don't need power because it's your voice that generates the current.
Of course, right. Yep.
Yeah, but so okay, let me jump back to dynamic microphones very briefly. The sound output from a dynamic microphone is very, very low. You're talking millivolts.
Yes, yeah, it would be. Yep.
So that's why you need to
Turn on your amplifier.
I need to turn on my amplifier, my preamp for it. So preamping before it hits the mixer.
So before we started today, folks, Dan, I can't hear myself. And he goes, oh, hang on, click, and turns his preamp on, which is down below the desk. So
yeah, and then we sit here and go wait for the tube to warm up.
Yes, we still use tubes in this day and age because they sound better than electronics.
Oh, yes, they do. Absolutely. How it works is that it applies the voltage to both of the signal lines equally.
Right.
Because for all of the microphones, the signal is the voltage difference between the two signal lines.
Right, okay.
So it doesn't matter what the voltage is on the signal lines, it's because it's the difference between it that's the audio signal. So you can shove 48 volts down it because talking into the microphone will modify that.
Right.
And that's what you get a signal. And that's why it's called phantom power, because you don't really see it.
Right, yes, okay.
And microphones that don't need phantom power, such as dynamic microphones, just ignore it.
Yep.
Because it's just the same voltage, so it doesn't matter. Yeah.
Very interesting.
And that's why, you can plug a dynamic microphone into something that's outputting phantom power and not destroy it.
Aha.
The other thing with microphones is you have different pickup patterns. So you have omnidirectional or unidirectional.
Right. So if I was to take a guess, that's to do with the shape of the bit of the microphone that gathers sounds, or
Yeah, exactly. So you've seen these pictures of like a thing, and then you've got like a mushroom cloud or whatever shape it is that comes out from it that shows you where it picks up the sound.
No, I don't know what you're talking about.
I'll put a picture in the show notes of it.
Okay.
So the microphones we're using are unidirectional, so it only picks up the sound from one direction mostly.
Right. So let's try this, shall we? So if I go to the left over here, if I just talk as I come across and go across to the right, something like that. So
exactly.
Right. Okay.
Yeah. So the idea is that we can sit across the table from each other and mostly not have the other microphone pick each other up. It does a bit, which is where noise gates come in. So if the signal is low, which it is if you're coming in the back of my microphone, it gets ignored.
Right. Yep. So I guess I can pretend a little bit that I'm completely dumb. Why do we have a microphone each? Why don't we have one microphone that we both talk into?
So that way, if we talk over each other, I can edit one person out, so it sounds like we haven't interrupted each other, or if someone sneezes into their microphone, you can kind of drop the sound down a bit.
So
things
there's
like that.
nothing wrong with having multiple recordings of different people so that you can do the fancy editing that you want to do.
Yeah, exactly.
Right, okay.
Yeah, and there is always a tiny bit of sound that bleeds through. It's impossible to have the microphone not pick it up at all. But
So my voice reflecting on the wall behind you back into your microphone.
Yeah.
But which is why sound studios have all this sound cancelling, baffling things on the walls, right?
yes, exactly.
Okay.
And that's why there's no echo in our voices as well.
Speaking of echoes and rooms with sound cancelling things, you've heard about the completely silent room, right? So there's this. Is it somewhere in the States, isn't it? There's some university or somewhere that's got this room that's just so perfectly set up. There's absolutely no way any sound can echo off anywhere and get back to you. So you go and sit in this room, and you can't hear anything, not a peep. It's dead silent. And apparently, it's just absolutely freaky. You start hearing your heart beating and your breathing.
Yeah.
And some people can only be in there for a few minutes. It's clunk. An example of why we have multiple microphones so we can get rid of that clunk. So these people that it's crazy. You can't actually be in there for too long because it sort of drives you a bit crazy or a bit mad. And that just goes to show that natural environment, there is always noise that we can hear, and we're accustomed to having this background noise, right?
Yeah, and even when you walk into this room, it kind of feels a little bit strange.
It does. It feels a little bit dead. A little bit, yeah.
And kind of like, I guess the best way to describe it is that you kind of feel like the room's kind of pressing in on you.
Different feelings to different people, not what I feel. I certainly, I know what you mean, but to me it sort of just feels like it just feels more dense in the room. So it's not, doesn't feel as light and as floaty as being outside with, natural sounds in the environment. But when you come into a quiet place, to me it feels dense, or like I'm walking into a compressed, well, I guess a compressed space,
Yeah. Right, so after you have microphones, I'm gonna gloss over this bit, which is all the stuff in between the microphones and the things that record it.
Okay.
Because it's probably less interesting to most people, which is the mixers and
Preamps.
And even the XLR cables.
Right.
And all that kind of stuff. So
XLR doesn't mean anything special other than just the way they plug in, right? Or is there some magic about them as well?
There's not anything particularly magic. They're just a cable. It's the connector.
Yep.
It's the XLR.
So it's kind of like the audio cable standard that's more than your fine little cable that comes on your headphones for your phone, right? So big bulky cable with a big, very reliable connector. Okay, let's move on. You didn't want to talk about it, sorry.
Yeah. And usually you're either going to go into an audio interface, which is, a USB or Firewire plugged into a computer, or into a mixer, and then into a computer. You see the pictures of the recording studios where they have these like massive, like 3 or 4 meter long desks with all the sliders and buttons and everything on.
Yeah, and I'm sure there are people out there, myself included, sometimes going, why do you still need all that?
Yeah, well, often you don't.
Okay. So why have they got it? Because the studio was built and when it was put in, it's still there and it's too hard to replace.
Yeah, and a lot of them are, analog.
Yep.
So a lot of bands have a particular sound, and that sound is from analog equipment.
Okay.
You see, I've watched a few videos of like road crews for big bands like AC/DC and people like that, and it's all still analog. The mixing desk, all the effects, it's all analog because it just has
sounds better.
Completely different sound.
So your mixer is not just volumes and things; it's all sorts of things, isn't it? Your modifications of the sound and adding echo effects and bits and pieces and things like that.
Routing of the sound and all that kind of thing. Like I want, the singer has monitors in their ears to listen to it, but they only want to hear, the snare drum, for example, and not the whole drum kit. Or,
right. Okay. Yep.
They don't want all the guitars or things like that.
So it's more than just having 1 or 2 microphones at a music concert, for example. You've got probably 100 or something listening to multiple different things, different types of drums and different guitars inside the guitar, outside the guitar.
Exactly.
All these sorts of things.
Yeah, like for example, bass drum, the kick drum.
Right.
You usually have a microphone inside the drum and outside the drum, and you mix those together to get the sound.
Oh, okay. fascinating.
Yeah. So when you mic a drum kit, it's like a standard drum kit, like snare, couple of hats and cymbals and everything, like 7 microphones.
Oh, wow. Okay.
Yeah.
So there's a bit more to it. Yeah.
Yeah.
And I suppose you want to route the sounds in different ways out the speakers as well. Perhaps you want to have certain speakers having more bassy instruments and other speakers
so
having
that's where
more voice.
crossovers come in.
Okay.
So a crossover basically says, right, so everything from this frequency goes this way and goes that way. So all the bassy stuff goes to the subs. And,
Right.
Yeah. So that's how that's handled.
So that's the stuff in the middle. Okay. So
Yeah,
we've
so it's
progressed
all
from microphones through to the stuff in the middle to what are we going to?
So recording. I'm kind of going to be podcast specific with this because we're doing a podcast.
Okay.
Even though I've kind of mentioned music a bit. So you have what are called DAWs, which are DAWs, digital audio workstations.
Right.
Which is pretty much just a computer with recording software on it. So you could go and get, free Audacity and put that on your computer, and it's basically become a digital audio workstation.
Okay.
So that's how we're recording. We're using a package called Reaper, which I have now paid for, Mike.
So for how long I've been coming here and I had to click through the evaluation window again.
It's like, yeah, I'm using it now. I should probably pay for it. Yeah, so you have those kind of software. There's, GarageBand for on the Mac, Reaper, Adobe Audition.
So Adobe does have an audio package.
They do. It's not amazing, but it does the job.
Which is interesting because they are the go-to for video and image editing, right? So it's interesting that they're not there for the sound editing.
Yeah, it's all right, and a lot of podcasters do use it, but things like Reaper, which I use, are a lot more powerful.
Okay.
Yeah.
Then there's like you're saying before, there's a free version or open source software package called Audacity.
Yeah.
Which is popular as well. So
yeah, and it works.
Yeah.
It's fine.
I think the most I've ever used it for is to try and invert a sound or reverse it or things like that, just because you want to try and find that bit of that song that they talk about. If you play it backwards, it's not true, but anyway.
And with podcasting, there's actually another thing of recording that's come about pretty recently, which is actually recording in your browser.
Oh, okay, right.
One of the big problems you have with podcasting, and this is kind of coming onto the internet as well, is people in multiple locations.
Right.
So you've all heard the podcast where sound
and
kind of
there's gaps in the voice and then it sort of gets all distorted and robotic sounding. Yeah, that's one. Yeah.
Yeah. So what these new software does is it records locally and then uploads it to the cloud.
Oh, right. So then the editor can pull that down and use that. Right.
So that's why the sound sync was off on the last podcast I released of TCBI.
Right.
Because I have to bring it down and combine my local recording with all these remote ones and kind of line it up.
Right.
And I didn't do a very good job.
Right. I actually haven't seen an updated copy of that come out yet, but anyway.
It should have. Anyway.
Trials and tribulations of technology and...
Indeed. So those are kind of the two ways that you record podcasts. I guess the third way is the good old recorder, which is a hardware device that takes audio in and records to an SD card or a hard drive or something like that.
Right.
And I use that as a backup recorder because computers crash.
Well, sometimes.
Yes. And it's always going to crash right after you've just done that important interview that you can't repeat.
Yes.
Yeah.
Or right as you're working on that thesis of yours and you haven't saved it for the last 8 hours and it's due in an hour and,
Exactly.
Yeah. Save early, save often.
Yeah. Right. So mastering. So that kind of brings back in like EQ and gate and compression and things like that. So mastering is taking, the raw sound and making it sound good, basically, because the raw...
Or the raw sounds?
Raw sounds, yeah.
So then turning those all into more raw sounds or one raw sound?
So
are you mixing them together for a final product for mastering?
So once you've mastered it, you mix it, which is bringing, So
you can't split it apart again after it's mastered?
Yeah, so you take, 50 tracks and turn it into 2, left and right for stereo.
Right, okay.
Yeah.
Sorry, left and right.
Yes. Yeah, because we have, so for example, if actually I've got my EQ turned off, but Mike, if you say, I know, something.
The quick brown fox jumped over the lazy dog. Like that?
Yeah. Do you hear the difference?
I kind of did, but I was trying to concentrate on remember what the sentence was.
Yeah, so basically I turned the EQ off on your track while you're in the middle of talking, and it kind of took away all the bass and everything like that, and you sounded a lot lighter, basically.
Okay.
So EQ, equalization, is taking certain frequencies and amplifying them.
So dealing with people with stupid voices.
Yeah, basically. So I have in my mastering software, I have mic on mic 1, mic on mic 2, down on mic 1, down on mic 2. So depending on where we sit, I apply a preset. Fixes the audio.
Very good.
Yeah, so for example, what I can do is I can take the really low sound and make myself sound really bassy, which kind of sounds a bit weird.
It does?
Yeah, so now I've got a really, really deep voice.
Very deep. Crikey.
Yeah. So that's EQ. It's basically taking it and changing the characteristics of the sound, and that's we have a thing called low cut, which basically chops off everything below what a human voice can't make. So you get rid of like the hums and all that kind of stuff from that.
So some background noises and things to try and, because I guess the ultimate focus is to try and take that sound that's recorded from that microphone and have just the human voice.
Yes.
But you're always going to have other stuff in the background, like my knocking the table like that, for example.
Yeah, or, even electrical noise, just the fact of, electrical signals running past the microphone cable generates sound.
Yes, good old 50 hertz hum.
Yes. Yeah, exactly. So, there's a lot of ways to prevent that, and that's why you spend so long cabling studios and things like that. And that's why microphone cables, the sound is the difference between the two.
Okay.
Because that way you have kind of a sum.
Is this balanced?
Yes.
Right. Versus unbalanced.
Correct.
So your balanced is your difference between the voltages. So you're 48 volts or you're 12 volts or you're whatever on the two lines, and then they're changing by this tiny little millivolt value, and that's your balanced signal. Yes?
Yes.
Right, okay.
And so that way you join them together, and that reduces the interference effect because you've got two values that you're measuring rather than one.
Okay, right.
Other mastering things, loudness. So that's how when you turn the radio on and you go between radio stations and, different songs, it's all the same loudness, so you don't change the channel and then suddenly have to turn your stereo down or up because the volume's different.
Oh, that's not always true, but you don't have to move it very much usually.
Yeah, but it's reasonably the same. Same with podcasts. There's actually a standard for loudness.
I might need to tell some of my people I listen to that there's a standard.
And there's a difference between loudness and decibels as well. So even though you get to a kind of a maximum decibel level with loudness set, the loudness kind of does it across the whole spectrum of sound. There's lots of tools out there for mastering as well. For podcasting, the best tool is Iphonic, which denoises, removes hum, normalizes the volume between all the people, sets the loudness, and it just makes it sound good, basically.
There's this web service that you upload your file to, and it does something and gives you a file back.
Yeah, cool. So that a lot of, you can't do it for music. You have to master that properly, which is why people that do that get paid the big bucks.
Right.
But for podcasting, you can generally get away with running it through one of these services, and it comes out sounding super professional.
Oh, cool. Okay.
I do spend a bit of time, it doesn't do EQ or gate or anything like that, so I do those bits.
Okay.
But then I go, let's just throw it through here. And it sounds good. I guess the last part about audio recording is the delivery of it. So that's, how it kind of comes back to the history topic of the medium, and this is where MP3s and compression and everything come in.
Okay.
So all the basic methods, like, you got an MP3 or a wave or a vinyl or things like that. But then we can talk about things like iPods and radio and streaming.
Okay.
So seeing as you want to talk about compression and everything, let's talk about compression and lossy versus lossless compression.
Right. So where I was getting to with talking about compression was that you start with raw analog sound, which definitely sounds the best, right? There's if you try and equate it perhaps to going to a concert, right? It always sounds better at the concert when you're at the concert listening to the actual thing. And then the recording, you're going to lose some sort of definition with that.
Mm-hmm.
And down the levels of how much definition you lose. So how high, what you call a sample rate for recording. So that's your 48 kilohertz that we're recording at now versus like, was it 8 kilohertz, I think, typically for around about
AM radio.
and like voice on a phone or you know your like there's a codec that's used. Everyone would have probably heard the term GSM for the mobile network that Vodafone used to run. Well, still do, but it's going away. GSM is 8 kilohertz, so that's why that phone voice is kind of sounds like it's not really a person, but it is because it's lost a lot of information because we're not because that sample rate. So kilohertz is number of samples per second that we're taking for the volumes and the levels.
That's how many times you're getting the ones and zeros.
Correct. Yeah. So and then you've got that file which is either highly accurate, you know, or 256 kilohertz or something, something really, really high. So just poke that closer to my mouth, Dan. Yeah, I'm bad at not sitting close enough to the microphone. I hate that image of eating it. And so then you have a very high quality recording of with high sample rate, and you get audio files wanting to keep their FLAC files, which are multi gigabytes for a song or whatever. So
they're not quite that bad.
Well, it feels that way. That not my thing. I'm quite happy to have a compressed version. So and then you take that high quality recording and in some way compress it to take up less space. I guess it's the main reason, isn't it, to try and be prudent about storage space or for
streaming, for internet bandwidth,
right, and things like that. So, and you've got two parts of compression, which is lossless and lossy. Mm-hmm. So, and it pretty much it means exactly what it sounds like. Lossless means there's no loss of quality, and lossy means there is.
Yeah, and basically that comes down to whether it pulls out information or not. So FLAC, for example, is lossless compression.
Oh, it is compressed. I thought it was raw.
It's compressed.
Oh, okay.
So WAVE is not compressed, and FLAC is compressed, but
not very much.
Less compression.
So not very much compression.
No, exactly. So it's so for example, it pulls out all the zeros, so that the blank spaces and everything like that. But for example, MP3, which is lossy compression, actually removes some of the samples or removes bits of the audio that usually don't really matter. Like they blend together.
Yeah, so we'll talk about. I think we've got an episode at some point where we're going to talk about compression or something, won't we? And in generic terms. But so Dan touched on it there a little bit, where one way to get rid of a bundle of information is you look for long strings of the same stuff. So rather than having 500 zeros, you put in one number that says 500, and you say the next number is 0. So 500 zeros.
Yeah.
So you've gone from 500 values down to 2 values.
Yeah, exactly. And that's still lossless compression.
Right, that's lossless. Whereas lossy is it's not easy to put an analogy in for it, but it's removing bits that the fancy the encoder that's taking the raw audio and converting it into MP3, for example, it's analyzing the sound waves and things, going, well, actually, you don't need to hear that bit because the ears won't hear it. So there's a whole bundle of rules in the encoder that says, I know what sounds need to be there and which ones we can kind of let slide because the human ear is not going to hear it. It's not going to matter.
Yeah, exactly. Yeah. I think that's probably about it.
So so a lot of audio recording. Haven't really touched on playback, but most people are familiar with that, I guess, a little bit in a way.
Your iPod or your phone, or.
But in essence, it's the same thing in reverse.
In reverse, so,
and it tends to be kind of that way in audio. You take an electrical signal, and in the very simplest sense, in a speaker, you energize a magnet, which moves another magnet, which is inside it, which is attached to the speaker cone and vibrates the ear, and you hear it. So it's kind of like a microphone in reverse. But
so basically, it's the diaphragm and the microphone, but outputting sound, and you can actually play sound through microphones.
You can. It sounds really weird.
Yeah, because it's essentially just a super sensitive speaker, and you can record sound through speakers as well.
Yes, and that sounds really weird too.
Yeah, but
there's differing levels of how much power you're getting out of a microphone to what you put into a speaker. So that's where it all comes to being different, right? So
yeah, and like for example, if we go back to the disc phonograph, it's instead of the sound going in and recording onto the stylus, stylus recording, the stylus is moving through the grooves, and that's putting the sound back out.
There's probably a question there saying you've got your needles that are either scratching us into the surface or one that's reading it. So how come the one that's reading it's not scratching into the surface?
As far as I know, it's because the surface is hardened.
Right.
So for example, a wax recording, the wax is,
Yeah, so it's like a cast is done, and then it's that cast is then used. That's effectively the master, right? In an older sense, is the cast of the wax or whatever, and then that's molded using that cast into a harder substance that the needle won't damage.
That's right.
Right.
Yeah.
Except if you heat up the vinyl enough, it does sort of fold and bend. And
yeah, or get a knife
warp.
out and
put a scratch down it.
Yeah.
The needle skips.
Yeah. Right, I think we probably wrap it up there.
I actually learnt something there, Dan. I've always sort of known about them, but it's not been my huge interest in microphones and speakers. But yeah, I like listening to nice sounds.
Yeah, and bit of exciting news. We've just confirmed that we're going to be on Otago Access Radio.
Yeah,
Mike's.
I'm still apprehensive and nervous about this. Right? This is kind of it's the internet. Nobody really listens to any of that stuff, but if it's actually being broadcast over the airwaves here in the local city, I'm a bit nervous about this.
People that know you are going to hear it.
Yeah, maybe.
And what we're actually going to do is, because the show has to be exactly 56 minutes on the radio, we're going to be releasing some bonus content that's just on the radio.
Do we know what we're going to add to this one for being just on the radio? It looks like it's going to be 9 minutes at this stage.
Not yet. I don't have an exact date yet for when we're going to start on the air, and we're actually going to go back to episode 1, the internet,
fun.
and release that first. But there will be bonus content at the end of every episode that you can only get if you tune in at the time.
They used to be on AM, but they're FM now, aren't they?
They're both.
They're both now?
They're both.
Oh, wow.
Yes, they have AM and FM, yeah.
I shouldn't be so mean.
And
I'm not a big radio person.
They stream live too.
Oh, really?
Yeah,
okay.
Stream live on the internet, so you'll be able to tune in and listen to yourself.
I think I'm on the very first bit of that generation where, radio and TV, while useful, and I've had my experience with them, and I'm quite happy to move on to sort of more on-demand things, streaming, and it's interesting. It's interesting the way society's going there.
All right, thanks for listening, and we'll see you in 2 weeks.
Yep, next time. Thanks, Dan.